This is particle to mass and mass to particle conversion. But before we look at this, we have to remember what particle is. Particle can be atoms, it can be molecules, it can be formula units. We've done that in the previous video. And when we talk about particle to mass and mass to particle conversion, you must already know about particle to mole conversion or mole to particle conversion and mass to mole conversion and mole to mass conversion. This particular calculation here is integration of the two. So if you do not know that, go back to the two previous videos and watch them properly. Okay? So let's start with the example. So example, what is the mass in grams of 9.31 times 10 to 21 atoms of carbon? Okay, then we underline what we know. We circle mass in grams, what we do not know. Then we look at the equivalent statements, and you are given some equivalent statements here to use. Any direct relationship between grams and atoms? None. None. No direct relationship, but we have to go atoms to, what can we go? Atoms to what before we go to grams? We can have atoms and moles. So equivalent statement is 1 mole equal to 6.02 times 10 to 23 atoms. Then conversion factor for this will be 1 mole over 6.02 times 10 to 23 atoms, or 6.02 times 10 to 23 atoms over 1 mole. So if you go from atoms to mole, then the next one will be 1 mole equal to molar mass. Now, mass, we have to look at molar mass of carbon. Molar mass of carbon, you can get that directly from periodic table, which is that. Then the conversion factor for that will be 1 mole of carbon over 12.01 grams of carbon, or 12.01 grams of carbon over 1 mole of carbon. So that means this is two-step problem. So we are going from atoms to moles to grams. One thing you know, mole is like a bridge. You can't go from one unit to the other without going through mole. It's like a bridge. Okay? So if you're going from atoms, you're going from grams, you must pass through mole. Take note of that, very important. So we are going from atoms to mole first. So that will be this equivalent statement. And we are going from moles to grams. That will be 1 mole of carbon equal to 12.01 grams of carbon. Then we set up the mass in grams. We know 9.31 times 10 to 21 atoms over 1. We follow dimensional analysis steps. to moles. So this will be atoms. Mole. These atoms of carbon, carbon, carbon. So 1 mole, we are using which one? 1 mole, then 6.02 times 10 to 23 atoms of carbon. These crosses are this. Then we are going from mole to grams. Mole to grams. So this will be mole of carbon, grams of carbon. We look at this. It will be 1 mole, 12.01 grams of carbon. This cross out this. Then we multiply the top and divide by the bottom. So that should be, I don't have a lot of space here. 10 to 21 times 12.01 grams of carbon divide by 6.02 times 10 to 23. So you put that in your calculator, and that will come out to be 0.186 grams of carbon. So that is 3 significant figures. So I hope you understand that. Do this, pause the video and do this practice question and see if you actually understood this. Okay, hopefully you did it. Let's look at it together. The question is, how many grams of sodium is equal to 6.92 times 10 to 21 atoms of sodium? So we underline what we know. We circle what we do not know. Then we look at the direct, is there any direct relationship between atoms and grams? Atoms and grams? None. So that means it's not one-step problem. So we atoms to moles. So the first equivalent statement will be 1 mole of sodium is equal to 6.02 times 10 to 23 atoms of sodium. So the conversion factor will be 1 mole of sodium over 6.02 times 10 to 23 atoms of sodium, or 6.02 times 10 to 23 atoms of sodium over 1 mole of sodium. That's the first one. So you go from atoms to moles. The next one will be moles to grams. So it will be 1 mole, that's the next. 1 mole of carbon equal to molar mass, of sodium, equal to molar mass of sodium. Let me remove this here and do it later. So in getting the mole of 1 mole of sodium, the molar mass of sodium, directly from periodic table will be 22.99. I hope you are checking your periodic table. So 1 mole of sodium over 22.99 grams of sodium. What am I doing here? Sodium, not carbon. Keep on using carbon. Or to 2.99 grams of sodium over 1 mole of sodium. Then we look at the strategy. We are going from, we know the atom digit of what you know to, first of all, remember mole is like a bridge, and then to grams. So here we are using 1 mole of sodium equal to 6.02 times 10 to 23 atoms of sodium. And here we are using 1 mole of sodium equal to 22.99 grams of sodium. So the setup, we want to solve for grams. That we know atoms, and that will be on top. Atoms of sodium over 1 times. So atoms of sodium will be here. Then mole of sodium will be here. So this will be from the equivalent statements. This will be 6.02 times 10 to 23 atoms and 1 mole. This will cross out. Now we're going from mole to grams. Mole to grams. So this will be mole of sodium and grams of sodium. So we looked at this, it will be 22.99, 1 mole. You cross this out. And the whole thing will be equal to 6.92 times 10 to 21 times 22.99 grams of sodium all over 6.02 times 10 to 23, which will give, put this in your calculator, you will get 0.264 grams of sodium. Yeah. So that will be to 3 significant figures. Okay, pause the video again and do these practice questions. I have more practice questions. The first one is, what is the mass of 12.4 molecules of carbon tetrachloride? Then number 2, convert 256.3 grams of sodium carbonate to formula units. Number 3, how many molecules are in 0.25 grams of dinitrogen pentoxide? Okay, pause the video and solve. Okay, hopefully you did this correctly. Let's do it together. Again, what is the mass of 12.4 molecules of carbon tetrachloride? 12.4 molecules. We know that we don't know the mass. Okay. So relationship between molecules and mass? No, but there's molecules and mole. So we start the equivalent statement. There's 1 mole of carbon tetrachloride is equal to 6.02 times 10 to 23 molecules of carbon tetrachloride. And then conversion factors will be 1 mole of carbon tetrachloride over 6.02 times 10 to 23 carbon tetrachloride, or 6.02 times 10 to 23 carbon, molecules of carbon tetrachloride over 1 mole of carbon tetrachloride. Then, when we go from molecules to moles, then we can go from mole to molar mass. Then 1 mole equal to molar mass, which is 1 mole of the carbon tetrachloride equal to, then we do the molar mass of carbon tetrachloride. We already know how to do that. That will give us 153.81 grams of that. And the molar mass will be, the conversion factor will be 1 mole over 153.81 gram of that, or 153.81 gram of carbon tetrachloride over 1 mole of carbon tetrachloride. Okay. Then what is our strategy? Strategy, we are going from molecules to moles, moles to grams. So this will be 1 mole of carbon tetrachloride equals to 6.02 times 10 to 23 molecules. And this will be 1 mole of carbon tetrachloride equal to 153.81 grams of carbon tetrachloride. So we solve for grams of carbon tetrachloride. Remember again, mole is a bridge. You can't go from molecules to grams to molecules without passing through mole. That's the bridge. So now this is 12.4 molecules of carbon tetrachloride over 1 times molecules here, carbon tetrachloride. This will be mole, so carbon tetrachloride. So we look here, mole is 1, 6.02 times 10 to 23 molecules times, I'm sorry, this is 2. Squeezed in together. So this and this will cross out. Then we have molecules of carbon. No. Moles. Ooh. Moles. Sorry, I have to cross it out. It's moles of carbon tetrachloride over grams of carbon tetrachloride. So here we have mole is 1. It's 153.81 grams of carbon tetrachloride, which will you multiply 12.4 times 153.81 all divided by 0.02 times 10 to 23. And that will give the answer to that. Let me calculate it out. The answer will be 2.17 times 10 to negative 21 grams of CCl4. Okay. Very tiny number. Then let's look at the second one. Convert to 56.3 grams of sodium carbonate to formula units. Here we are going from grams to, let's see, grams to formula units. Grams to formula units. So we underline, we circle, then we find the equivalent statements. So we're starting from grams. Grams to what? To how do we get the formula units? No gram and formula unit, but we have grams to moles. So we will have 6.02 times 10 to 23 mole. I mean, what am I doing here? Grams to moles, I'm sorry. It will be 1 mole equal to molar mass. That's how we start this one. 1 mole equal to molar mass. And calculating the molar mass of sodium carbonate, it will be 1 mole of sodium carbonate equal to molar mass of sodium carbonate is 105.99 grams of sodium carbonate. Okay. Then the conversion factor, that I have enough space. So I will not write down this conversion factor because of space. It will be 1 mole over sodium carbonate over 105.99 grams of sodium carbonate, or 105.99 grams of sodium carbonate over 1 mole of sodium carbonate. And then the other equivalent statements will be, we'll now go from, if we go from grams to mole, we go from gram to atom. So that will be 1 mole of sodium carbonate is equal to 6.02 times 10 to 23 formula units, okay, of sodium carbonate. Then the strategy will be, we are going from grams to moles to formula units. So we have 1 mole of Na2CO3 equals to the molar mass is 105.99 grams of sodium carbonate. And now we are going from 1 mole of sodium carbonate is equal to 6.02 times 10 to 23 formula units. Okay, now we want to set up. We want to calculate how many formula units. So this will be 256.3 grams of sodium carbonate over 1 times, sorry for the, I'm writing too small, grams sodium carbonate over mole of sodium carbonate. So that will be, we look here, mole on top, then we have 105.99 grams times mole of sodium carbonate, no space. Then we are going to formula units of sodium carbonate. So the formula unit will be 0.06.0223, then 1 mole. This will cross out, this will cross out, this cross out, this will cross out. And that will be 256.3 times 6.02 times 10 to 23 formula units divided by 105.99, which will give, what's the answer? It will be 1.46 times 10 to 24 formula units of 24 formula units of sodium carbonate. Okay. I hope you got that right. And I want you to also practice number 3 on your own. Pause the video and practice number 3 on your own. And this is the answer. Hopefully you did. This is the answer to number 3. Okay. I hope this makes sense. Thank you.